Assalamualaikum warahmatullahi ta'ala wabarakatuh, and welcome to MCTE 2311 Signal and System Analysis. In this video, I will talk about classification of signals part 2, which means from this classification of signals that we will look into in our course, I will talk about this second half of the types of signal. Let's start with stationary and non-stationary signal. So stationary signal refers to the signal whose statistical parameters such as amplitude, standard deviation, or mean are constant over time, which means the long-term statistic does not change with time. Okay, and it can be recognized from a differential equation with a constant coefficient. Okay, for example, the omega naught here is a constant. And you can look at this graph over here. Okay, so if you look at the graph here, you can see that it has a fundamental period of 200 milliseconds. Okay, and where the signal is repeating itself at every 200 milliseconds. So this type of signal, the long-term statistic does not change. For non-stationary signal, it refers to the signal whose statistical parameters are not constant over time, okay, which means the long-term statistics will change with time, okay, and it can be recognized from a differential equation with a time-varying coefficient. Okay, for example, if you look at the equation here, this t is a time-varying coefficient. And if you look at the signal here, you can see that okay, with respect to this time period, okay, it does not repeat itself. Okay, you can see that from 0 until 300 millisecond, the signal here has a very high frequency. Okay, however, from 300 to 600 millisecond, the frequency started to become a little bit slower, and then slower again from 600 to 800 millisecond, and much slower from 800 to 1000 millisecond. Okay, so for this type of signal, the long-term statistics will change. Now we look at energy and power signal. Energy signal refers to a signal that have finite total energy and zero average power. Okay, and the total energy contained in a signal can be calculated using this formula. Okay, and example of energy signal are deterministic and aperiodic signals. For power signal, it refers to the signal that have finite average energy and infinite total energy. The average power contained in a signal can be calculated using this formula, okay, over here. An example of power signal is periodic and random signals. Power signal can also be calculated from root mean square of signals, or RMS. Okay, the relationship between power and root mean square, or RMS, is given by this formula: P equals to RMS square. And if you have a sinusoidal wave, okay, there is sine wave or cosine wave, the RMS is equals to A over square root of 2. And if you have a triangular wave, the RMS can be calculated using this power, okay, A over square root of 3, where A, okay, in both of these formulas, this A and this A is the amplitude of the sinusoidal and triangle signal. Next, we look at even and odd signal. So even signal refers to the signal that is symmetric about the y-axis. For example, if you look at the signal over here, you can see that this part over here, okay, is the mirror image of the part over here. Okay, so we can see that g of t, okay, so this part is g of t, is equals to g minus t for all t. The even part of a function g of t can be determined using this function. An odd signal refers to the signal that is symmetric about the origin. Okay. For example, if you look at the graph here, okay, so this part here is actually the negative mirror image of this part. Okay, so they're symmetric about the origin. So this one is symmetric to that part. The odd part of function g of t can be determined using this equation. Next, we have transient signal, which refers to a signal that occurs for a certain duration of time. Okay? For example, like this signal, it occurs for only a short period of time before it dies out. Okay, so the most common example of transient signal is the exponential signal, which is given by this equation: x of t equals to b e a of t, where b and a are real parameters. Okay, so if a is less than 0, okay, this a less than 0, you will have an exponentially decaying signal. If a is greater than 0, you will have an exponentially growing signal. Okay, for example, this graph here, okay, you have a equals to minus 1 over 2. Okay, and the amplitude, which is b here, is 2. So you have an exponentially decaying signal. This one here is an exponentially growing signal. Okay. Now, this one, problem example 1, okay, there are two questions here. The first one asks you to find the total energy of the signal given here. And the second question asks you to calculate the average power of a periodic signal of fundamental period of 10, described over one period by x of t equals to minus 3t, okay, in between t5 and minus 5. Okay, so then problem example 2 asks you to find the average power. Okay, so you can see you have here cosine and sine function, okay, in all three equations. So in this example, you can use the relation between average power and RMS, okay, to calculate the average power of the signal. For example 3, involves the even and odd function. Okay, so why don't you go ahead and try solve all these problem example, and I will also give the solution to all of these problem examples in the next video. So thank you, and I see you later.